Hello there, and welcome to Bedtime Universe. Tonight, we turn our eyes and our curiosity toward one of the rarest discoveries of our age. A faint traveler slipping through our skies, a quiet messenger that did not grow up beneath our Sunday. Astronomers have given it a name you may soon learn to recognize: 3I Atlas. It is not a comet of the familiar family that circles our star. It is an object from somewhere else entirely. Another stellar neighborhood, another time, another set of conditions that shaped its dust and ice. For a brief while, by chance, and by the careful watching of telescopes, a piece of a distant planetary system drifts past our sun and whispers to us about places we may never visit. Tonight, let us lean back, let the day's voices fade, and follow that whisper as far as our imagination and the data will allow. His story begins almost invisibly. It was first noticed as a faint point of light, a tiny wisp barely standing out against the crowded star fields of the southern sky. Discovery cameras gathered their nightly sweep. The survey pipeline flagged a moving dot, and human eyes, still the final arbiters of surprise, took a closer look. The object's position shifted from frame to frame, just enough to betray its motion. The orbit solvers went to work, and the numbers refused to fit the usual stories we tell about comets and asteroids. This path wasn't a closed ellipse like a long-period comet returning from our own distant Oort cloud. It was hyperbolic, an open arc that says, as plainly as a plot can say, "I am not bound to the Sunday." In human terms, it is the difference between a neighbor stopping by and a traveler from far away passing through town on a journey that began before we were watching. The telescopes named the Find 3I Atlas 3I because it is the third confirmed interstellar object we have observed, after one I, Oumuamua, in 2017, and two I divided by Borisov in 2019, an extraordinary addition to a very small club of cosmic nomads. NASA Science +1. There is a practical geometry to its visit, and geometry makes a soothing kind of bedtime truth. Astronomers can say when and where the visitor will come closest to the Sunday. Their calculations show that 3I Atlas will make perihelion its nearest approach to our star around the 30th of October 2025, at a distance of roughly 1.4 astronomical units. That's a little farther out than Earth's orbit and close to the orbit of Mars, about 130 million miles, or 210 million kilometers from the Sunday. It will not swoop in tight enough to blaze into a spectacle for casual eyes. It will remain modest, a subdued guest keeping its distance. Its closest approach to Earth will also leave it well beyond our immediate neighborhood, on the order of 1.6, 1.8 AU. So there is no danger in its passage, no drama, just the elegance of celestial mechanics, carried out far from harm. NASA Science +1. Before perihelion, its road threads the realm of the red planet. Models indicate a pass that places it tens of millions of miles from Mars in early October, a distant hello rather than a handshake, enough that orbiters there may try for a careful look, but far too distant for anything like a close-in encounter. For most of us on Earth, this will remain an event we meet through images and spectra rather than with our own eyes. The comet will slip behind the sun from our point of view, briefly hidden in the glare, and then reappear in early December, fainter, receding, and already beginning the long exit that its orbit demands. There will be no fireworks. The quiet is part of the story. Star Walk +1. What makes a distant fragment worth such attention is that it functions as a natural sample box from beyond the solar system. Every comet or icy body that forms around a star preserves, within its dust and ices, a memory of the environment where it coalesced. The temperature profile of its disk, the abundance of volatile molecules, the radiation bath of its young sun, the collisions that shook pieces loose. An interstellar visitor, like 3I Atlas, is a messenger carrying a foreign chemical dialect. When light passes through the gas and dust around it, the coma, that ghostly shroud that surrounds its nucleus-specific molecules, leave fingerprints called spectral lines. By measuring those lines in infrared wavelengths, scientists can reconstruct a list of ingredients and, from that list, infer something of the kitchen, where the recipe was first mixed. Here, the observations are especially intriguing. Early sensitive spectra, most notably from the James Webb Space Telescope, reveal that the coma is unusually rich in carbon dioxide compared to water. In fact, the CO2 to H2O ratio, measured for 3I Atlas ranks among the highest recorded for any comet observed near the Sun, a signal that stands out from the statistical trend seen in familiar long-period and Jupiter family comets. Alongside CO2, observers have identified H2OCO, water, ice, dust, and even traces of OCS, carbonyl sulfide, each identification an extra syllable in the object's chemical accent. The coma appears somewhat asymmetric, with enhanced outgassing toward the Sun, suggesting patches of active terrain responding to solar warmth. All of this points to a nucleus, intrinsically rich in CO2, perhaps formed near the CO2 ice line of its birth disk, or processed in a radiation environment unlike our own backyard. Whether because water sublimation is suppressed or because carbon dioxide was abundant from the start, the balance tips decisively toward CO2. And in that tipping, models find new constraints. To imagine what that means, picture two kitchens making the same basic recipe. One uses more salt, the other more sugar. The final tastes are both recognizably the same kind of dish, yet different in ways that reveal something about the cook and the pantry. If comets are recipes of ices and dust, then 3I Atlas adds a new seasoning to our cosmic banquet. By comparing its spectrum to comets born here in our system, scientists can begin to sketch the range of conditions that produce planets and small bodies across the Milky Way. A high CO2 content can suggest formation in colder regions of a protoplanetary disk, where carbon dioxide can condense into ice more readily than water, or formation under different radiation and chemistry. These are not speculative metaphors, but pieces of a forensic puzzle. Carefully measured lines, emitted photons, and dynamical histories combined to reveal origin stories. The beauty for a bedtime mind is that the forensic details are quiet and exacting numbers stacked like smooth stones, while the picture they build is grand, a planet-making factory in a distant system, leaving a breadcrumb that drifted across the galaxy and, for a night or two, into our instruments. Because 3I Atlas arrived as a faint wanderer rather than a blazing show, our study of it requires patience and rigor. Observatories across the world pool their measurements. Photometry that tracks how its brightness changes with distance and viewing angle. Spectroscopy that reads its chemical fingerprints. Astrometry that refines its precise motion through space. Each dataset tightens uncertainty. How large is its nucleus kilometers across or only a few hundred meters? How fast does it rotate? And does that rotation modulate outgassing? Is the flow from vents steady or sporadic? And does the coma carry large grains or mostly fine dust? Even small signals matter. In previous interstellar visitors, minute, non-gravitational accelerations from outgassing sparked debates about surface properties and internal structure. With better instruments, faster alert pipelines, and a global network of follow-up telescopes, 3I Atlas offers a richer, earlier look than we had for its predecessors, letting the community test competing models of formation and evolution, with a dataset that is, night by night, becoming beautifully overdetermined. There's history in this lineage of visitors. Oumuamua arrived without a visible coma, a dark shard with puzzling accelerations that launched years of discussion. 2I divided by Borisov swept in as a more classic comet, with obvious outgassing and a relatively ordinary composition. 3I Atlas seems to split the difference in its own way, clearly cometary, yet chemically tilted, modest in brightness, yet generous in information. Together they form a small but growing sample, enough to begin asking population questions. How common are such objects in the solar neighborhood? How many pass unseen every decade, their faintness hiding them from our surveys? What fraction are CO2, rich like 3I Atlas, and what fraction look more like typical Oort cloud comets? Each answer helps to connect the dots between protoplanetary disks across the galaxy and the raw materials that feed worlds. Beyond the data tables and plots, there is the human dimension. For a century, we've trained ever larger and more sensitive eyes on the sky. Survey telescopes that scan the heavens nightly, spacecraft that see in colors our eyes cannot detect, and networks that ping alerts worldwide when an unusual object pops into view. The discovery of 3I Atlas is a product of that vigilance, of software and glass and human curiosity arranged into a planet-scale listening device. It is humbling to remember that these tiny bits of rock and ice, flung out of their home systems during chaotic early epochs, can wander through the interstellar medium for millions to billions of years, and then, by mere geometry, pass within reach of our attention. The scale is almost absurd. Dust grains mixed with frozen volatiles endure unimaginably long journeys, and in a single sleepless night, someone at a console can catch their faint signature. Hold that contrast for a moment as you settle into the rhythm of your breath. Slow in, slow out. Think of the scale: the sun at the center, the planets in their lanes, and far beyond, the region where comets from our own cloud sometimes fall inward. Then think farther. Stars scattered through the thin disk of the Milky Way, each with its own retinue of debris. Somewhere out there, in a system that once had its own giant planets and its own jostling ice balls, a small thing was nudged by gravity, tossed outward, and set free. It coasted in the dark for an age, almost silent except for the low hum of interstellar radiation and the occasional dust grain pinging its surface. And then, this year, it wandered into our sunlight and began to breathe molecules shaking free and sparkling into a temporary atmosphere. That is 3I Atlas, not a loud visitor, but one that turns sunlight into a whisper we can read. The numbers themselves can be a lullaby. An astronomical unit, AU, is the average Earth-Sun distance. 1 AU is about 150 million kilometers. 3I Atlas will shave a little closer to the Sun than 1.4 AU, and it will keep well beyond 1.6 AU from Earth, which is a way of saying comfortably far. Light takes just over 8 minutes to cross 1 AU. At 1.4 AU, photons travel to and from the comet in something like 19 minutes. Meanwhile, the object cruises along its hyperbolic track with a speed that will peak near perihelion, then slacken as it climbs out of the Sun's potential well. We won't see it loop back. The curve is an open door that will not swing shut while any human alive today is still listening. If you enjoy small rituals, there is one you can perform on clear nights. Step outside and find a patch of sky that feels quietly yours. You won't see 3I Atlas with unaided eyes, but you can feel the architecture of its passage in the way the planets array themselves along the ecliptic, and the way the Milky Way drapes overhead like a scarf of old light. Somewhere within that arrangement, careful instruments are measuring spectral lines, slim fingerprints, where molecules bend and stretch in infrared colors. And from those lines comes a picture: CO, 2 tallies, far outpacing H, 2O, CO present but quieter, OCS, making a cameo, water ice scattering light as fine frost in the coma. The ratio of CO2 to H2O is a diagnostic. If you could write the chemistry of this comet as a fraction, CO2 would tower, H2O would be a modest denominator. It's not that water is absent, it's there, in vapor and in ice, but in the contest for dominance. Carbon dioxide is the unanticipated winner. That simple fact forces models to adjust. Perhaps the nucleus has shallow thermal penetration, preventing deeper water-rich layers from heating. Perhaps the topmost veneer is CO2 rich. Because of the chemistry of its nursery, perhaps both are true. Science welcomes such forked paths. Each offers a test. Behind the scenes, orbit computers continue to refine the comet's hyperbolic elements. Its eccentricity, comfortably greater than 1, its inclination, tilted and retrograde with respect to the planet's flow, its precise timing around perihelion. Even the Precovery images, older observations that happened to capture the object before discovery, may be folded into the solution, lengthening the observation arc and tightening the uncertainties. There's a quiet satisfaction in that, the way librarians feel when a misplaced volume is found and returned to the shelf. And in that satisfaction, a deeper calm, the sense that even when the universe arrives as a surprise, we have the means to situate it cleanly within our understanding. Once you know to look, the engineering of attention is everywhere. The Atlas survey that spotted this visitor was designed as a planetary defense tool, 4 small telescopes that sweep the sky for moving things that might one day matter to us. Most nights their finds are routine. Main belt asteroids, near-Earth objects that miss us by healthy margins, comets that glow politely and return to distant aphelia. But every so often the feed carries a point of light that follows a path only an outsider would take. A flag goes up. A note goes out. Follow-up observations pour in from amateur and professional observatories alike. The pipeline is global, almost musical in the way it passes themes from one instrument to the next. Discovery, confirmation, characterization, modeling, testing, each movement informed by the last. 3. iAtlas is a testament to that planet-wide vigilance. A reminder that we are, right now, living in an era of real-time cosmic listening. NASA science. If you're the kind of listener who likes to picture the hardware, imagine Webb's near spec pointing into a star-crowded field. Starlight filtered out. The comet's faint glow spread into a spectrum like a secret laid flat. In that spectrum, a series of dips and peaks, absorption and emission features, mark the vibrations of CO2, the rotational fingerprints of H2O, the telltale notes of CO and OCS. Each feature is tiny, measured in microns and millijanskis, but it is enough. Webb is sensitive to whispers. From that whisper, astronomers derive mixing ratios, outgassing rates, even directionality. A sunward lobe, where molecules stream faster, a nightside lull where the surface stays colder and quiet. Others on the ground add visible light photometry, polarimetry to gauge grain sizes, and high-resolution imaging that catches the coma's texture. What began as a point becomes a profile. What began as motion becomes a biography written in sunlight. The philosophical delight is that all this precision sits easily beside wonder. You can let numbers reassure you, perihelion dates, distances, signal to noise, and still allow your mind to drift outward into the story implied. A small ice rock, freed from its system by the nudge of a giant planet or the jolt of a collision, coasts through interstellar night. It encounters almost nothing for an immense span of time, then glides into the outskirts of a new star's gravitational field. As it falls inward, sunlight begins to do chemistry on its surface again. Cracks open. Molecules stir. The coma blooms like a slow flower whose petals are atoms and grains. For a few months, the object acquires a voice we can detect. And then, as it rounds the sun and departs, that voice fades. Silence resumes. In between, we took notes. There are practical ripples too. Each interstellar object we characterize adds to population statistics. How many such wanderers pass within, say, 5 astronomical units of the Sun each year? With better surveys coming online, will we catch more before perihelion in time to mount focused campaigns? Could we ever intercept one, send a dedicated probe to fly by, or even to sample? The questions are no longer fantasy. Trajectory planners have run scenarios. Engineers have drawn up rough concepts. The time from discovery to launch is the hard part. For now, we do the next best thing. We gather a thorough remote sensing dossier while the traveler is within range. The archives that result. Spectra, images, astrometry will be mined for decades, serving as benchmarks for the next discovery and the next. If interstellar objects are reasonably common, they likely play roles in planet formation and chemistry throughout the galaxy. Some models imagine them as seeds, nuclei that, when captured by a young disk, can act as condensation sites for local material. Others see them as couriers, moving organic molecules from one system to another, contributing a sprinkle of complexity wherever they go. These are not settled questions. They are the kinds of hypotheses that sharpen with data. And 3. I-Atlas, with its CO2 heavy character, gives the models a very specific constraint to meet. If a disk makes many objects like this, what does that say about its temperature structure and radiation field? If it rarely does, what exceptional pathway produced this one? In both cases, the universe becomes less vague. Let's pause and shrink our scale again, not to kilometers or microns, but to the human. Somewhere tonight, a graduate student is coaxing a difficult spectrum into shape, subtracting skylines, flattening fields, and checking calibration lamps with the concentration of a watchmaker. Somewhere else, a team is writing a pipeline to cross-match observations from a dozen facilities, aligning epochs like beads on a string, so parameters can be fit and refit. These are the sleepers of tomorrow, their work tucked into archives that future readers will open with gratitude. And in living rooms and backyards, amateurs turn their telescopes towards star fields marked with red circles on finder charts. Most will see nothing but the field. 3 I-Atlas is too faint for small instruments under most skies, but the act of trying connects them to the project. The night sky is a commons. Even when we cannot see the current guest, we can watch the place where it is and feel the pleasure of sharing a sky that hosts things we are only barely able to know. Just as sleep comes in gentle thresholds, so does the exit from our story. After perihelion, as the comet rounds the sun, the outgassing will ebb. Dust released near perihelion will continue to trail along the orbit, a thin ribbon growing ever more diffuse. The nucleus, having warmed and vented, will cool again as it heads outward. Gravity will not call it back. The hyperbola carries it away. It will cross the realm of the outer planets, pass through the cold confetti of the Kuiper belt, and then the darker emptiness beyond. Its next encounter of note may not be for millions of years, and even then it may only be a slight nudge, a statistical whisper rather than an event. The universe is a patient editor, and yet a trace remains. The data this visitor leaves behind, spectra, astrometry, images, will persist in our repositories. There, its CO2 rich signature becomes a line in a catalogue, a figure in a paper, a footnote in a textbook a decade hence. A future student might compare it with the chemistry of a newly found planet's atmosphere and notice a rhyme. Or a future mission designer might use its trajectory as a test case for an intercept concept study. In that sense, 3 I-Atlas achieves a small immortality. It etches itself into our collective memory not as a spectacle, but as a datum with edges crisp enough to be picked up and used. That is a lovely kind of permanence, modest and durable. If you find yourself wondering whether such encounters are portents of larger mysteries, keep one steady thought in mind. The universe is rich in regularity and surprise in equal measure. 3. I-Atlas is neither proof of life elsewhere nor evidence of anything supernatural. It is a natural outcome of dynamic planetary systems, of physics and chance. Still, its passage touches something deep, the sense that our world is not alone in a sterile emptiness, but participates in a lively galaxy where matter moves, exchanges, and occasionally delivers pieces of one cradle of worlds to another. For children, for dreamers, and for young scientists, that idea is generous. The cosmos is not merely backdrop, it is a network of stories. And sometimes one of those stories arrives at our doorstep, written in a hand we can learn to read. So as your eyelids grow heavy and the shoulders of the day relax, picture for a moment the faint wisp of light that was noticed in the southern sky. A visitor named 3I Atlas, carrying the slow handwriting of chemistry and history. Imagine telescopes waiting like careful readers, intent on a fragile manuscript, passing the letters of ice and dust to reconstruct a sentence about a place unimaginably far away. Let the technicalities that it comes nearest to the Sun around October 30, that it remains distant from Earth, that its coma sings in the voice of carbon dioxide be part of the lullaby. The precision of numbers woven into the fabric of wonder. Breathe out, and let your mind drift along the slow arc of this traveler as it moves onward through the galaxy. Remember that even the faintest light can bring a message. The universe is larger and stranger and kinder than we sometimes imagine, and every so often it sends a traveler to remind us. Good night from Bedtime Universe. And now, as the night grows deeper and the world grows quieter, let us drift into our next journey. A story carried on the darkness above us, a story written in light. Tonight, we will follow what poets once called a river across the heavens, a gentle current of stars flowing silently through the sky. This story is called The Quiet River of Stars. Close your eyes and picture a place without the noise of lamps or screens, a place where the air settles cool on your skin and the horizon is a clean black bowl. In that bowl, the river appears soft, milky, faint at first, as if someone brushed white chalk from one horizon to the other. This is the band of our own galaxy seen from within, a sideways view of the spiral disk that holds us. People have named it for as long as we have looked up. A road of light, a milk spill of the gods, a path for souls, a sky river. Astronomers give it a simpler name, the Milky Way. But names are just doors. The wonder is what you feel when you step through. If your eyes are dark adapted, 20 minutes without bright light, no phone, no car, headlights, the band lifts itself out of the background. You begin to notice texture. The river is not smooth. It is threaded with dark inlets and quiet eddies where the light thins. Those are not holes at all, but lanes of interstellar dust, thin as smoke and wide as light years, drifting between the stars and absorbing their glow. Along the band are brighter knots and hazy patches where new stars are kindling inside clouds of hydrogen. Somewhere near the middle, low on a summer night in the south, the river swells into a soft bulge. That is the direction of the galactic center, toward the constellations Sagittarius and Scorpius, where the star clouds are dense and the dust lanes cut like long black rivers within the river. We stand on a small world circling a very ordinary star. Our sun is a yellow-white dwarf among hundreds of billions, set out on a suburban lane called the Orion Arm. Some call it the Orion Cygnus Arm, or simply the local arm, a minor spiral lane between two larger ones. Perseus on one side and Scutum Centaurus on the other. From this neighborhood, we look edge-on through the disk, and the light piles up, star behind star behind star, until the sky looks like spilled milk to the human eye. If you could jump out of the galaxy and look from above, you would see the disk as a broad spiral about 100,000 light-years across, with the sun not at the center but off to one side, roughly 26 to 28,000 light-years from the core. Numbers can feel large. Let them slow your breathing. A single light-year is the distance light travels in a year. The starlight taking shape as that pale band tonight began its journey long before your grandparents were born, and in some parts of the band, long before humans ever spoke. There is a black heart at the center, but not empty dense, a supermassive black hole we call Sagittarius A*, about 4 million times the mass of our sun, sits in the core like a city's weight under all the light. Around it, the bulge is crowded with old stars. Their orbits are tight, their dances swift. Astronomers have watched some of those stars loop the black hole in short centuries and decades, their paths bending under a gravity that is both invisible and absolute. You cannot see any of that from a dark field, of course. What you see is the echo. The middle of the river grows brighter and wider, and the dust lanes cut across it like slow thunderheads. Downstream and upstream from that swelling, the band thins and threads through the constellations like a silk ribbon. Through the tail of Scorpius, through the teapot shape of Sagittarius, up past the eagle Aquila, across the bright cross of Cygnus and its long tail to Deneb, curving toward Cassiopeia's crooked W in autumn, and back down through the horns of Taurus in winter. Listen to the quiet of that river. Beneath its light is a weather of gas and dust, mapped not by clouds and rain, but by faint glows at specific colors. Hydrogen, breathing in a deep red, we call H-alpha. Oxygen in a soft teal, dust grains scattering blue like smoke. The glow is not a roar, but a whisper. New stars form in cocooned nurseries. The Orion Nebula, a flowering knot in the sword of Orion. The Carina Nebula, bright and knotted in the southern sky. The Lagoon and Trifid in Sagittarius. Side by side, one, a wide pool of glowing hydrogen, the other, a pale blossom banded by dust. In those places, gravity gathers gas until the pressure and temperature rise high enough for hydrogen to fuse into helium and light, and a star is lit. For millions of years, radiation and stellar winds carve caves and pillars out of the clouds, and when the most massive stars end, they end with a generosity that shakes their neighborhoods. A supernova enriches the surrounding gas with heavier elements, the stuff of planets and rock and you. The river recycles. The river teaches the same old lesson softly. Endings and beginnings are parts of one flow. Where you stand matters. At mid-latitudes, the Milky Way arches like a great bridge from south to north in summer. In the tropics, the core climbs high, and the river thickens overhead, finer texture, more star cloud, more dark lane. In winter, the band tilts, and though the core is hidden on your side of the planet, the river still threads through Orion and Gemini, lace-fine and quieter. From the far south, different reaches are revealed, the Southern Cross standing near the riverbank like a marker. We forget, under city domes and office ceilings, that the sky changes with season and latitude. The river reminds us if we let it. The facts can be gentle if we speak them softly. The disk that makes this band is not flat as a plate. It is warped, as if a slow hand had lifted its edges unevenly. The sun and its planets ride a wavy midplane, dipping above, then below the disk, over tens of millions of years. Our star orbits the center at roughly 200 kilometers per second, and a full lap around the galaxy, the so-called galactic year, takes something like 200 to 250 million Earth years. Think of that. One slow turn of the river's wheel, and the calendar on your wall is emptied 1,000 times. In that span, continents drift, mountains lift and wear away, new languages are born and forgotten, and the sky rivers for every creature who looks up is both the same and not quite the same, because our vantage point is always moving, always slightly changed. Far beyond the disk are the globular clusters, old and round, each a ball of ancient stars, hundreds of thousands gathered into spheres that drift in the galaxy's halo like lanterns at a festival. They are not on the river itself. They are like lights hung in high trees along the banks, thick with red giants and blue stragglers. Their chemistry, old and spare. Look for M13 in Hercules, a hazy cotton knot with a steady heartbeat of stars. Look for 47 Tucanae in the south, a larger, brighter hive of sun candles, densely packed. Those clusters are fossils of early times. The river runs newer in the disk, where gas still pools and stirs. There is a quiet address you can memorize if it helps you sleep. You live in the local bubble, a kind of low-density cavity in the interstellar medium, likely carved by ancient supernovae long ago. That bubble overlaps with your neighbor's bubbles like soap suds, and on its walls, new stars have been born and will be born. You live in the Orion Arm, part of a barred spiral galaxy roughly a third of the way out from the center. Your sun is one of hundreds of billions. Many of those stars have planets. We know this now not as a guess, but as a repeated measurement, a song of small dips in starlight, of tiny wobbles, and split spectral lines that mean a world is tugging. Somewhere, on some night under a different sky, someone could point up and trace their own river, and know that a small world is looking back, equally curious and equally tired in the good way of a long day's end. Turn your mind along the river's route, and let it walk by landmarks you may know in name even if you've never seen them raw. There is the Great Rift, a long chain of dust lanes running through Cygnus, dimming the river and dividing it into two pale streams. There is the North America Nebula, a red map of a continent in hydrogen glow. There is the Aquila Rift, a darker branch. The star clouds of Scutum, the small, bright M24, sometimes called the small Sagittarius star cloud, like a window where the dust thins, and you can see deeper than usual. There is the Pipe Nebula in Ophiuchus, a simple L-shaped darkness that stands out simply because it has the courage to be black against all that light. Each one is a piece of texture. Each one is a reminder that the river's softness is made of millions of hard-edged facts. If you lifted above the river, if you climbed out of the disk and looked back, the band would fold itself into a grand design. A central bar, spiral arms unwinding, star formation, tracing those arms like frost blooming along glass. Tidal interactions with small satellite galaxies tug on the edges. The Magellanic Clouds leave a stream of gas, like a wake on the galaxy's sea. Dark matter unseen, but weighing far more than all the stars, holds the whole structure together, an invisible frame carrying most of the mass. You do not need the details to rest. It is enough to know that the quiet you feel beneath the river is supported by something strong and steady. And there is a future even for rivers. Long from now, so far that it occupies the part of the mind where fairy tales live. The Andromeda Galaxy and the Milky Way will draw together. They already are. Andromeda is coming toward us slowly in human terms, and quickly in cosmic ones. In several billion years, the two spirals will begin to interpenetrate and merge. It will not be a crash of suns. The spaces between stars are so large that very few will meet head-on. Instead, orbits will reshape, gas will rattle and compress, bursts of star formation will ignite, and the final result will be a new, larger galaxy with a new shape, a new river. No one you know will be there to see it. But somehow, the knowledge feels soothing. Even grand structures have arcs to their stories, and change at that scale is a tide you can let lift you into sleep. Perhaps you are listening from a city, and the river is hidden behind a dome of light. That is all right. Part of the story of this river is that it is patient. It has waited for eyes to look up in deserts and on ships, and in mountain meadows, and on quiet balconies, when the power went out and the night returned to its ancient depth. If you ever find yourself somewhere dark on a beach after the moon sets, on a hillside at 2 in the morning, on a ferry deck where the wind keeps you awake, give your pupils time. Turn off the lamp. Let the cones in your eyes rest. Let the rods take over. Let the glow sharpen. At first you will see grey. Then the grey will thicken into a woven cloth. Then a dark seam will run through it, and a bright knot will appear, and another, and the river will be there, in a way no photograph can quite teach. Breathe in, and let it lay a hand on your shoulder. If you want a simple ritual to bring you closer to the river from anywhere, try this. Imagine your mind is a slow raft. Set it upon the band of light, and let it drift. As you float, count gentle truths instead of sheep. 1. The light of Deneb has been traveling for more than 1,000 years to reach you. It left the star when empires were drawing new borders on parchment and never stopped. 2. The sun is circling the galaxy. Tonight you moved many thousands of kilometers around the center without feeling a thing. 3. The atoms in your blood were made in stars. The iron in your hemoglobin was built in the core of a dying sun before the Earth existed. 4. Somewhere deep in the band are clusters where stars are born every year from dust and gas, their infant light pushing away the very clouds that sheltered them. 5. The river you see is the edge-on sum of 100 billion worlds, all real, all turning, all warming their own nights. By the time you reach 6 or 7, You will feel the river pulling on you in the way a lullaby does, not with force, but with belonging. It is not just sight that brings you into the river's quiet. There is the sense of scale, spacious in a way that gives room to whatever you carried to bedtime. A worry that filled your whole day can sit on the riverbank for a while, not gone but smaller against the spread of things. There is the rhythm of cycles, short and long, your breath, the beating of your heart, the rotation of the earth, bringing night and day, the sweep of the moon around us, tracing tides. The path of the earth around the sun, bringing seasons. The sun's path around the galaxy, bringing epochs. The galaxy's future dance with its neighbors, bringing transformations. Each cycle holds what came before. As you listen, you are held too. For those who like details tucked under the pillow, there are a few more to rest on. The disk of the galaxy is not just stars. It contains spiral waves, patterns where gas and dust compress and release as they orbit, like cars bunching and separating on a ring road. Where the wave compresses, star formation lights up, and the arm looks brighter. Between arms, the light softens, but does not end. The dust lanes are not dirty. They are the raw material for future light, and they redden starlight, passing through them the way a sunset reddens the Sunday. On clear, moonless nights, observers in very dark places can see the zodiacal light, a faint triangle along the ecliptic, sunlight scattered by dust within our own solar system, the Gegenschein, an even fainter brightening opposite the Sunday. These small additions are like fireflies near the bank, joining the river but separate from it. If rhythm helps you rest, we can set the story to one. The river rises in the south, flows up through the Eagle, crosses the Swan's Back, passes the Queen's Chair, and falls again toward the Hunter's Belt by winter, then settles, then returns. With every return, you are a little older, and so is the light you see, but the pattern holds. This is the part of astronomy that feels like a kind hand. The sky is not a puzzle to be solved and set aside. It is a companion you can visit. The more you learn of its facts, the more it rewards you with feeling. Knowing the name of a nebula does not steal its mystery. It adds a note to a chord you already love, and still, beneath all the texture and all the numbers, there is the simple act of lying back and letting the white band pour across you. Somewhere along that band, on a small world with a name we have not learned, another listener may be doing the same, letting their mind drift along their river, counting their truths, thinking their own future, and carrying their own day into the kind night. When you share the river, you share something large without needing to own it. The light is given freely. The time was paid long ago by the stars themselves. If you find your thoughts wandering to distances and durations, let them. Let the mind take a slow walk. Light crossing the space between stars, collapsing gas, warming into stars, planets taking shape from rings of dust, like snowflakes growing on a windowpane, oceans forming, air thickening, creatures lifting their eyes. None of this is rushed. The river has room for slow stories. Your story is one of them. Now the night grows deeper still, and the world grows quieter still, and the river goes on doing what it has done since before there were people. It gathers the light of uncountable suns into a band we can understand at a glance. Not everything has to be solved. Some things are here to be trusted. The Milky Way is one of them. You can rest beneath it without finish lines or arguments. It will still be flowing when you wake. So breathe in and breathe out, and let the quiet river of stars carry you. If your eyes are closed, picture that soft band and the dark lanes braided through it. Picture the bulge low on the horizon, like a slow sunrise of far-off suns. Picture the way it arches up and over, east to west, season to season, age to age. If your eyes are open and lucky enough to be in the dark, let the band have you whole for a minute. Let it make every small noise in your life seem smaller, and every kind thought seem larger. In the end, that is what the river is for. It is a reminder that we live inside something vast and patient and ongoing, and that our day's bright, messy deer are carried along by a current we can trust. When you are ready, you may set your raft against the bank and step into sleep. The river will be here when you drift back in the morning. It always is. It always has been. Good night. May the hush of the galaxy be the hush of your room. And may the quiet river of stars guide you gently, steadily, all the way into rest. And now, as the night settles deeper and the world loosens its grip, let us lean into a quieter orbit. Take a slow breath in, let it drift out, and imagine a small, golden circle turning in the dark. No countdowns, no roar of engines, just a record, patient as a heartbeat sealed to the side of a departing machine. This is our next journey. It begins with a needle and a groove, with a message pressed into metal and launched into forever. Tonight's story is called The Voyager's Golden Record. Picture a room late at night, lights low, a turntable waiting. You lift a record from its sleeve, hold the warm weight in your palms, then set it down. A stylus lowers, a hiss like distant rain. And then, voices, music, thunder and birds. The sound of a mother greeting a child. You are not alone anymore. You are connected by a ribbon of vibrations to the place where the recording happened, to the air that trembled when those words were first spoken. That's what a record can do. Now take that feeling, that thin golden bridge between two moments, and pull it longer, until it spans not a room or an hour, but a solar system and 1,000,000 years. That is the ambition tucked inside two small spacecraft named Voyager. In the late 1970 seconds, two identical probes were guided onto paths that would carry them past the outer giants, Jupiter and Saturn for one, and for its twin, still farther, to Uranus and Neptune. The timing was rare. The big planets happened to line up in a way that allowed each encounter to sling the spacecraft to the next. A gravitational hopscotch called a grand tour. The Voyagers carried cameras and detectors to read magnetic fields and count charged particles, to sniff the chemistry of atmospheres and measure dust. But they also carried something not required by any engineering specification. A phonograph record, plated in gold, tucked into an aluminum case on the spacecraft's body, with instructions etched into the cover. The idea was simple and audacious at once. If anything ever found this craft adrift in the deep dark, the record might be played. It might speak for us. Gold is patient in space. It does not rust or cloud easily. The record itself is copper, gold-plated for endurance. On its jacket, diagrams explain how to use it, how fast to spin it, how to position the stylus, how to decode the pictures stored as a rising and falling signal. A map points back to us, using the pulsing hearts of dead stars' pulsars as waymarkers, their ticking frequencies engraved in a universal unit set by the spin flip of hydrogen. There is even a tiny sample of radioactive material on the cover, so that a careful future reader could measure its decay and know how long the record had been traveling. It is a time capsule that provides its own clock, its own compass, and its own instruction manual. What does it say? Almost everything it can, in the small space, aloud. There are greetings spoken in dozens of languages. Hellos, welcomes, well wishes, small messages of peace sent from a planet that is not always peaceful. There are sounds of Earth, wind, surf, thunder, crickets, footsteps, a heartbeat, a kiss, the machinery of our living tractors in a field, a train crossing a bridge, a rocket trembling a launch pad. There are songs, music from many traditions and centuries, string quartets and choir, blues that aches with cold nights, drums that call to dancing, a bright guitar that once made teenagers in diners move their feet. There is a lone voice saying, "Hello from the children of planet Earth." A sentence so simple and clean that it feels like a lighthouse blink from shore to far sea. There are pictures too, encoded as sound and meant to be retrieved by drawing their lines back out. Images of our bodies and our homes, of mountains and rivers and cities and farms, of a mother and child, of a page of mathematical definitions, of a human hand with a circle scribbled beside it to help with scale. There are scientific diagrams, biochemistry, the structure of DNA, a portrait of our star and its family of worlds. And somewhere in that gallery, there is a photograph of the blue sphere that holds all of this, suspended in black. It is both more than enough and not nearly enough, but it is a start. The two voyagers rode their rare paths with breathtaking success. They flew by Jupiter and watched its storms roll, and its moons show themselves as worlds in their own right. Volcanic Io, with plumes blooming above its yellow plains. Icy Europa, scored with lines like cracked glass. Ganymede, big enough to have its own magnetic field. Callisto, old and cratered like a memory of the early solar system. They dove by Saturn and saw the rings as a structure, not a band, braided, scalloped, shepherded by moons that carve gaps, the way boats cut channels through ice. One voyager pressed on to the pale worlds farther still, showing Uranus tilted like a rolling barrel, and Neptune dark-eyed and windy. And Triton, its moon, framed by geysers that wrote weather on an air as thin as a thought. They saw things nobody had seen. Then, after the cameras took a last look home and turned off to save power, the spacecraft kept going. At some uncertain boundary, the sun's breath gives out. The bubble that our star blows into space, our heliosphere ends, and the interstellar medium takes over. The voyagers pushed through that boundary and reported the change. The direction of magnetic fields shifted, the density of particles altered, the texture of the radio hiss around them changed. Out is not a cliff, but a slow crossing, a gradient from familiar to wider. Out there, their energy comes from a small supply of heat, set free by the decay of a metal inside them, changing to electricity through devices that conduct heat like a one-way street. Every year, power fades. Every year, instruments shut down to keep a few core senses alive. There are long silences now. Sometimes a message is garbled, sometimes a whisper returns. But the craft still move, writing their thin lines through a diagram which no one can hang on a wall except as a metaphor. A map of leaving. Sometime in the far future, even after the last instrument is silent, the records will remain. They will drift with their carriers through a medium that is not quite empty. If no one ever finds them, then the message will have traveled for nothing but our own benefit, because crafting it made us ask, with unusual clarity, who are we, and what do we want to say? That was always part of the point. But there is another possibility that is gentler and strange, that one day, in a time so far ahead that we might as well call it a fairy tale, someone will notice a weak, moving point against their own constellations. They will track and predict and meet. They will bring the patient thing aboard a metal flower long since cold, painted in dust, and they will open the case and consider the diagrams. They will find a stylus included and an image on the cover that shows what to do. They will spin the disc at the speed indicated by a small etched number. They will press the needle into the groove. The first sound will not be words. It will be a thunder of surf and wind and water, camera-shy and ancient, an ocean speaking one syllable in every language. Then perhaps a greeting will arrive in a tongue never heard beyond Earth before. A hidden part of their mind might react without any shared dictionary, because the greeting sounds like a greeting no matter what you know. The cadence of someone addressing someone else with attention. A child's voice may follow. Music will arrive that is built on ratios common to our bones, even if not to our culture. What would they make of a 12-bar blues night? Of a string quartet bidding evening to a rose? Of a voice from the desert singing to dawn? Let the question be a soft horizon line. It's enough at bedtime to look toward it, not to answer it. After sound, pictures, they will feed the signal into a scanner and watch as lines bloom into images. The first is simple, a circle that tells you where the edges are, a calibration to help your eye know what it is seeing, then a page of units, then a tree, a landscape, a city, a mother holding a baby in a way that makes a lump rise in your throat, even if you have never held one, a spectrum of the sun like a barcode, the DNA double helix climbing a ladder of numbers, the chemical alphabet of life, a handshake, a grocery store, a photo of a schoolroom where someone drew a triangle and called it truth. It's not everything, but it's our handwriting in the margin of the universe, legible to anyone who is patient with puzzles. Now come back for a moment to the tabletop with the turntable and the soft light. Imagine that it's you who is the one finding the record, because in a way, every time you remember that it exists, every time you play in your mind what it contains, you are the receiver at the edge of the dark. What does the record say about us? It tells of our curiosity, the way we cannot help pointing lenses at things and asking them to give up their secrets. It tells of our variety, many languages, many rhythms, many rituals to navigate joy and grief. It tells of our technical discipline we can measure. We can etch a map with pulsars and trust that anyone who can travel across the void can read it. It tells of a small humility too. Tucked among the confident diagrams are the sounds of frogs and rain and laughter, as if to admit that what really matters about us is not only what we know, but how we live. The record is a mirror. It reminds us that to be human is to hold the world in your ear for a while and listen. The cover art is itself a poem. On the left, a setting showing how to play the disc, how to drop the stylus, which side to choose, how to set the speed. Above, a clock tick drawn from the atom most common in the universe, so that anyone with a physics and a radio can reconstruct our unit of time. On the right, a map of pulsing lighthouses, their tick rates etched in the same time unit, so that triangulation from a few will point to the place where the record was launched. At the bottom, an outline of the disc and its stylus, with the stylus drawn in a different position to represent time passing during playback. It is all very practical and at the same time very beautiful, like the diagram of a musical instrument a careful maker might draw. Who chose the contents? People with different expertises sat together and argued kindly about what could not be left out. A physicist who had sent messages before. A writer with a fierce tenderness for life. Musicians and linguists and scientists who kept asking, "Do we have room for this? What about this?" They were limited not just by space measured in minutes and megabytes, but by the reality that every inclusion is an exclusion. For every song there is 1,000 not included. For every picture, 1,000 lives just outside the frame. They did their best. If, one day, you are awake at 3 a.m. and feeling like a gnat on a window pane looking out at a rainstorm, it can be steadying to remember that a small committee of humans worked very hard to give the universe a fair sample of what it feels like to be us. Perhaps you've heard of one last photograph. A Voyager took a portrait of home from far away, where our planet is a pale dot caught in a shaft of scattered sunlight. Even if you haven't, you can feel what such a view would do to a person. The way it presses the breath out of you without panic, leaving you lighter. The record carries that same perspective, but in sound. The great far away made intimate. You put your ear to a circle of metal, and a breeze moves through the leaves of a tree you will never sit beneath. You hear the fluting of a bird whose name you do not know, and you do not need to know. A single voice says hello, and you are a little less alone. There is a quiet, practical courage in sending a record into the dark. It admits that we are not the center of everything. It admits we may not be listened to. It admits we want to be known anyway. It is the act of a species that sometimes sets a table for a guest who might never arrive, simply because that is who we hope to be. A record is a table. A groove is a plate. A stylus is a knife and a fork negotiating warmth from something that was cold when you set it down. Let's imagine an unwrapping, then, on a world not our own. A being like us in curiosity and different from us in almost everything else kneels beside the artifact. They puzzle out the diagrams and, with a few false starts, they coax the first audio out of the groove. They smile, or whatever their version of smiling is, because the messiness of analog comes through. A pop here, a hiss there, the voice of a singer riding a ribbon of noise like a surfer on a break. They adjust. The music steadies. Then, maybe because this is what music does, they look up from the machine and out into the open, and something about the line of their horizon looks kinder for a moment. They have just learned that somewhere else, minds arrange sound to make time feel less lonely. They do not know our words for it, but they know what it is. If the record is found not by strangers but by none at all, it will continue on, slumbering in a black that is never truly empty. It will outlast mountains on Earth, and languages, and perhaps our species. It will travel through regions of space, where the density of atoms is a handful per cubic centimeter. Then through fluffier deserts between spiral arms. Then perhaps brush against a tendril of gas licking out from a passing star. It will warm slightly as it passes invisible fields, then cool slightly, keeping its counsel. The message does not care. The message is content to be available, to exist as an offering beyond the reach of the offered. Sometimes, when people speak of this record, they argue. Should we advertise ourselves? Should we have said more? Should we have asked less? These are reasonable worries, because the world is not a perfect host for its own inhabitants. Why would the universe be kinder? But there is a different symmetry to consider. When you tuck a note in a bottle and set it on the tide, you are not merely hoping for an answer, you are naming yourself to yourself. You are saying, I am the kind of being, How writes, who hopes, who greets. The record says this about us. We are makers of grooves and listeners to echoes, builders of diagrams and tellers of jokes. We are a family, as primitive and as refined as that word implies. So let the night stretch thin now. Let the turntable in your mind spin. Listen as the track list steps from thunder to a child's voice, from heartbeat to horn, from a crackling campfire to a violin, tracing the outline of a horizon you can't see but recognize. The room you're in, bed, pillow, window, takes on the comforting attention of a spacecraft's small body. Instruments stowed, systems powering down, the golden disk secured. Somewhere, many times farther than you have ever traveled, two such bodies are still coasting, long past the last planet, carrying the warm proof that we tried to say hello. And when your eyes start to close, picture that etched cover, the hydrogen clock, the map of pulsing stars, the diagram of the player, the invitation written in geometry. Imagine a hand from far away following those lines centuries from now, with the patient curiosity of the best readers. Imagine the first ounce of sound spilling into a room that has never known Earth. Imagine the pause afterward, the most human of all silences, the one that means, I heard you. Then let your breath make that silence in your own room. Now, softly, we have reached the outer edge of our little tale. The turntable slows, the stylus lifts, the record moves back into its sleeve. The spacecraft keeps going, small and faithful, turning its golden ornament to the stars like a locket. You are here, on a blue world where wind has its own music, and morning will return. You can sleep, knowing that somewhere in the dark, our best hello is still on its way. Good night, traveler. Good night, record. And to you, listening in the quiet, thank you for keeping watch with me until the end of this track. Okay, this journey of galaxy end here.